Alright, so the next case that we have is in the situation wherein we have sine ax or cos ax. That means if your f of x is in the form of some sine function or a cosine function. Alright, so in that case what you will have to do, it is of the form, for instance, sine of 5x plus 2, or maybe just sine of 5x. So in this case your a is the number that is attached to x, so a will be 5. Okay, so this is basically what you're going to do. Alright, so now what we do is, in this case, as usual, we'll have yp is equal to 1 upon f of d on the sine of ax plus b. This is applicable for cos as well. Okay, for sine and cos. Nothing about tan or sec. Sine and cos. Okay, now what we do here is we replace d square, not d. We replace d square by minus a square. We replace d square by minus a square. This is how we go about with it. So now this is what we'll do. Supposing I have yp is equal to 1 upon d plus 1 operated on sine 2x. Now we don't see a d square here. We don't see a d square here because my aim is to replace d square by minus 2 square, because it should be minus a square. So in other words, minus 4. Alright, so I don't see that here. So what I need to do is, I have to somehow bring a d square into the picture. So how do I bring a d square into the picture? I will multiply and divide by d minus 1. So this is what's going to happen. So I have yp, which is equal to 1 over d plus 1 operated on sine 2x. So for sine and cos, I need to see a d square. So yp becomes, I'm multiplying and dividing by d minus 1 upon, I'm multiplying this also by d minus 1. So what does that become? It becomes d square minus 1 operated on sine 2x. Now what I do, where I see d square, I replace d square by minus 2 square, which is minus 4. So what will this become? So yp will become d minus 1 upon minus 4 minus 1 will be minus 5 operated on sine 2x. This is equal to minus 1 upon 5. What is d? D, capital D is nothing but d by dx. That means capital D operated on sine 2x is nothing but derivative of sine 2x. Derivative of sine 2x will be 2 cos 2x minus 1 into sine 2x will be sine 2x. So your yp over here is minus 1 upon 5, 2 cos 2x minus sine 2x. So this is how you're going to be working with sine and cos. So if there is no d square term, somehow you have to bring a d square term into the picture. Alright. So there's another problem that is done. So here you have a problem that's given. So you can go through this problem and check to see how you find the particular integral. So if you look at it over here as well, you have 1 upon d minus 3 sine x. So what is the number attached to x? The number attached to x is 1. So d square will have to be replaced by minus 1 square, or in other words, d square will have to be replaced by minus 1. But the thing is that we don't have a d square. So what do? We'll have to multiply and divide it by d plus 3. That's what they have done in this step. They've got a d plus 3 in the numerator, and d minus 3 into d plus 3 gives you d square minus 9. So where there's a d square, replace it by minus 1 and then work it out accordingly. So this is an example that you have, which you can basically go through. So this is basically case 2 for sin x and cos x.